I'm Santiago and I'm a second-year student at MCC's Honors College. This past spring, I did my independent study on my hydraulic fracturing and the environmental concerns and regulatory shortfalls related to it. The Honors College allowed me to embark on some undergraduate research, which is very uncommon for a freshman year student. It also gave me a sense of the world around me by letting me look outside of the college bubble, and it even connected me with an advisor that had connections in my field of study, which is geology. My project goals were to understand what the process was and to actually participate in some testing by going down to South Texas and collecting some water samples. I wanted to test the samples in our chemistry lab to get some experience with lab work, and I wanted to present some possible improvements to the process too. Fracking is taking place in Texas, in the South Texas area for the most part, in the Eagle Ford Shale. The Eagle Ford Shale is pretty close by San Antonio. The main issue that we're seeing right now is that San Antonio and any other counties near it get most of their drinking water from the Carrizo-Wilcox Aquifer. As you can see, the Carrizo-Wilcox Aquifer and the Eagle Ford Shale are almost directly stacked on top of each other. Private landowners in Texas have a lot of rights to their land, which includes the rights to the water beneath their land, so they can do with it as they please. Fracking in Texas is connected to the worldwide economy. It's going to cause a major economic boom in the San Antonio area, which leads regulators currently to figure out how they're going to regulate the process, since it's still fairly new. Hydraulic fracturing has been around for about 70 years. It's very common. It's used in about 9 out of 10 oil sites. It's happening in 3 main locations in the United States: the Midwest region, the Four Corners area, and as of recently, Texas itself. This leaves environmental agencies scrambling for how to regulate fracking in Texas right now, since it's the newest location. Here's a brief animation on the process. I want to draw your eye to 3 main locations on this image. The topmost part is the actual well site, the blue layer is the water, and the dark brown layer is the shale that they're trying to reach to collect the oil and gas. The vertical drilling phase takes about 2 weeks to happen. They encase their drill in concrete or cement so as to prevent contamination from happening. The drilling continues to get to the target shale location. The level that the shale is at varies from fracking site. It could be way up there or way down there. Kickoff point happens 500 feet above the shale that they're trying to reach. They go in horizontally so as to make it easier for pressure to push the hydrocarbons back upwards. The next step is to perforate the well. They put in a perforation device which breaks down little holes in the shale. The next step is actual pumping of the water. They bring tankers of trucks and just pump in thousands of gallons of water each day to break down the shale and let it seep into the punctures that they made the step prior. This is an image of the fracturing process actually taking place. All the thousands of gallons of water are presenting a lot of pressure, so it breaks down all that shale. The hydrocarbons are then released and pushed upward by the force of pressure. Now the final step is to reclaim the well site and leave it to how it was before. However, they only collect about 80% of the water that they pumped in out. So there's still 20% of water stuck down there in the ground. There are 2 main national regulations in place right now. They're the Safe Drinking Water Act and the Clean Water Act. The Safe Drinking Water Act tells U.S. people about how clean their water should be safe to consume. And the Clean Water Act tells corporations that they should not pollute in water that is meant to be consumed. There are also varying regulations at the state level. There are 3 main causes for concern currently. There's a non-enforcement of the set regulations. The EPA is having a bit of trouble agreeing with states on how to regulate the fracking process. Next concern is water pollution. This image right here shows the shale layer to be much closer to the well site, to the groundwater. So there's always an off chance that that fracture could reach up and contaminate water that we drink with oil and gas or any of the other chemicals that they're using. The last concern is of grave importance to Texas. We're a state that's very prone to droughts, and all the water that these oil and gas companies are using per day measures in hundreds of thousands of gallons. This right here is an image of an acre-foot of water, which is how they measure the water use. An acre-foot of water is about 360,000 gallons of water. Texas House Bill 3328 was passed last year by Governor Rick Perry. It told oil and gas companies that they must disclose what chemicals they're using in their treatment, and it even set up a website called fracfocus.org, which set up a registry for people to actually look at what chemicals each well site is using. However, the Trade Secrets Act allowed the oil and gas companies to keep some of the chemicals secret because they make money off of it. They derive independent economic value from keeping those chemicals secret. Okay, my field that I went to was located in Atascosa County, Texas, which is near San Antonio, close by it. Here's a picture of a well site. We had to take this picture from off the road since they would not allow us into the actual well site. I collected 8 water samples. Half of them were from private land and half of them were from water treatment plants. The half from the private land were able to be collected because my advisor knew somebody in the area that was glad to see a student test his water samples. And the 4 samples from the water treatment plants were collected with permission from the proper authorities. I brought back my 8 samples to MCC's chemistry laboratory. You can see them up there in the top left. I ran them through a dichloromethane titration process. Dichloromethane and water do not mix, so whenever you put the two together, you get 2 distinct layers. When I put my sample water in there, I got 3 distinct layers. I got dichloromethane, water, and any contaminants present. These contaminants were collected in little vials and run through the gas chromatograph mass spectrometer, which is basically a machine that identifies what chemicals in your vial. 7 out of the 8 samples were fairly clean. However, sample 4, which was collected from private land, had 2 distinct spikes right after the dichloromethane initial spike, which was present in all the other samples. Those spikes were identified as tetraethylene glycol di-2-ethylhexanoate. I typed that into the computer and brought up a United States patent that stated that it had been used as a low fluid loss foam. A low fluid loss foam is used in fracking sites to make the water thicker and easier to collect whenever they're pumping it back out of the ground. More common uses of this chemical, though, are as an artificial flavoring ingredient. However, there were no food manufacturers in that area when we went down there. There are 3 main steps that I'm going to take in the future. I'm going to collect further water samples from around that area, as well as monitor any state or national regulations that are introduced. And I'm also going to keep in touch with the residents of the area to see if I can go back onto their land and collect more water samples. The Honors College connected my major to a current issue that's of great importance right now. And it sparked my interest in additional field work. I realized that science isn't all about lab work. You can actually go out there and get dirty, have some fun. And it also allowed me to partake in some social interaction with people. I didn't just do my scientific research, I also talked to people and got their side of the story. Thank you very much.